Hello students, welcome to Mass Academy. In this video, we are discussing Term 3 examination for Grade 9 Advanced, EOT 3 for Grade 9 Advanced. In Physics examination, there will be 20 questions and 2 bonus questions. Out of these 20 questions, 16 questions will be online examination, that's computer based examination, and questions will be multiple choice. You have to select one answer, and the next 4 questions will be paper based exam. You have to write your answers in the answer sheet provided, and the next 2 bonus questions, that will be also paper based. You have to write your answers. The 20 questions I have divided into 10 concepts, and in this video we will discuss all these 10 concepts in detail. And the questions I will be discussing in the order of the concept, not in the order of the question numbers given in the EOT. For example, the concept 1, that is work, and we have 3 questions from this topic in EOT, that is question number 1, question number 8 and question number 7 in EOT are from this concept work. So first, question number 1, identify work as a scalar quantity measured in Newton or Newton meter or joule. So what is work? What is the definition of work? Work, we can write how to define work. Work is the product of force along the direction of the displacement multiplied displacement. So how to define work? Work is the product. Product means multiplication. So work is the product of force and displacement. What force? Force along the direction of the displacement and displacement. So we will write like this. What is work? Work is force along displacement multiplied displacement. So if there is a question to write the definition of work, you can write this equation, or you can write just like this. You can write what is work. Work we represent by the letter W. We use the letter W to represent work. So work is equal to force multiplied displacement multiplied cos theta. In this equation, what is work? What is W? W represent work, F represent force, D represent displacement, and what is cos theta? Cosine of the angle. What is this angle? Theta is the angle between force and displacement. What is theta? Theta is angle between force and what? Force and displacement. Force and displacement. Okay. So W equal to force multiplied displacement multiplied cos theta. The next is here we have an object here, and you are applying a force on this object. F is the force you are applying on that object. So this object is moving along this floor. Okay, so this is the floor. This object is moving through a displacement. It was here. Now the object is here. The object moved to here. So it moved through a displacement D. You can see it moved through a displacement D. So force along this direction to the right side, displacement also to the right side. Force and displacement are in the same direction. So this is the direction of the force and this is the direction of the displacement. So if force and displacement are in the same direction, then what is the angle between them? Angle between them is equal to 0 degree. If 2 quantities are in the same direction, if they are in the same direction, when force and displacement are in the same direction, the angle between them is equal to 0. So what is the value of cos 0? That you can check in the calculator. Cos 0, check in the calculator, how much? 1, right? Cos 0 is equal to 1. So if you apply this value of cos 0 in this equation, the equation become like this. Work done is equal to force multiplied displacement multiplied cos 0. What is the value of cos 0? 1, right? Displacement multiplied 1. The force multiplied displacement multiplied 1. So it will be force multiplied displacement, right? No need to write that 1 here. Okay, so if force and displacement are in the same direction, the angle between them is equal to 0. So if the angle theta is 0, the value of cos 0 is equal to 1. That you can check in the calculator. If you think why it is 1, you check in the calculator. So cos 0 will be 1. Then we will check the unit. Okay, what is the SI unit of work? SI unit for work. What is the SI unit of force? Tell. What is the SI unit of force? SI unit of force is Newton, right? So SI unit of force is Newton multiplied. What is the SI unit of displacement? SI unit of displacement is meter. Unit of displacement is meter. So unit of work done, that is equal to unit of force Newton multiplied unit of displacement meter. So Newton meter is the unit of work. Newton meter is the unit of work. This unit is called joule. Joule we represent by the letter J. Next we are discussing question number 8. Question number 8 is to calculate work done using the equation. So we will discuss some questions from the textbook, and this question is page number 192 of your textbook, grade 9 advanced INSPIRE textbook. Example problem 1. So in this question, a hockey player uses a stick to apply a constant force of 4.50 Newton. So force is given in this question. Force is equal to 4.50 Newton. And what else is given? The mass of the object which is experiencing the force, that is given as 105 gram. 105 gram. And displacement is also given. The force is applied over a displacement of 0.15 meter, right? Yes, 0.150 meter. So displacement is given. Displacement is 0.150 meter. And we have to calculate what? We have to calculate the work done. So in this question, we know the equation to calculate work done, right? Work done is equal to force multiplied displacement multiplied cos theta. This equation will be given in the examination. So work done is equal to force. Force how much? Force is 4.50 Newton. 4.50 Newton multiplied displacement how much? 0.150 meter. So 0.150 multiplied cos how much? Angle not given. Theta is not given in this question, but we know that when the force is applied, the object, the puck, is moving along the direction of the force, which means the angle theta is 0, right? Why is 0? Because the force and the direction of motion of the object are same. The force and displacement are in the same direction. The puck is moving along the direction of the applied force. So angle theta between force and displacement is 0. Value of cos 0 will be 1. Anyway, if you use this in the calculator, use a calculator to solve. 4.5 multiplied 0.15 multiplied cos 0, that is equal to 0.675. 0.675 and unit of work is joule. So 0.675 is the answer. 0.675 joule is the work done on the puck using that hockey stick, right? Yes. Okay, so there is a confusion here, like here this is given, mass is given, correct? So what the students do, some students will try to use this value mass somewhere. So here do we have to use mass? No. If there is like a more data given in the question, you don't have to use it. You have to use what? You have to use what is required in the equation. If there is something extra, ignore it. No need to use it. Okay, don't use this in the somewhere in the equation. No need to use that. So this is an extra data given in the question, which doesn't mean you have to use it. Okay, what you have to use what is required in the equation. Check, is force given? Yes, force is given. How do you know which is force? You will know from the unit, right? Force will be in the unit Newton, so that is force. Displacement will be in the unit meter. So you need force, it is given. You need displacement, that is given. You need the angle, you know that they are moving, it is moving in the same direction of the force, so angle theta is 0. So you got the angle also. So mass, that you don't have to use in this while solving this question. From the page number 192, practice problem question number 3, a rock climber wears 7.5 kilogram backpack. So mass is equal to 7.5 kilogram backpack. While scaling a cliff, after 30 minutes, the climber is 8.2 meter above. So here time given, time is how much? 30 minutes, and displacement is given 8.2 meter above the ground, above the starting point. Okay, so how much work does the climber do on the backpack? So we know that work done is equal to force multiplied displacement multiplied cos theta. So here force is not given, but mass is given, and in the previous question I said if mass is given, ignore it, right? So here the situation is different, the context is different, that you need to understand. In the previous question it was like this. So this is our ground. In the previous question the object is here and a force is applied on the object and the object is moving along this direction. So displacement, right? And force and displacement are given. Okay, so we used force and displacement, and in this question it is different. Here the object is here, okay, the backpack, and here the force is applied, means the object is moved in the upward direction, right? Not along the horizontal direction, it is moved, means the person is lifting the object. So if any object is lifted, so I will write lifting. So to lift an object, for example, to lift my bag, if I am lifting this object, lifting this backpack, how much force I need to apply it? So while lifting, the force needed, force required, that is equal to weight of the object, that is equal to weight of the object. So what is weight? mg, mass multiplied 9.8. So if the object is lifted, the force is equal to weight of the object. So here how much is the force? Force is equal to weight of the object mg. So what is mass? Mass is 7.5, right? 7.5 multiplied g is 9.8. How much? 7.5 multiplied 9.8. 7.5 multiplied 9.8 equals 73.5. 73.5. Force is unit is Newton. If mass, unit is kilogram. Okay. So work is force multiplied displacement multiplied cos theta. So what is the value of force? Force we have calculated now. So we got 73.5. 73.5. In which direction he is applying the force? He is applying the force upward, right? So in what is the displacement? Displacement is 8.2. In which direction is the displacement? Displacement also upward, force upward, displacement upward. So what is the angle? Angle is 0, right? So cos 0, why 0? Because force and displacement are in the same direction, equals what? 73.5 multiplied what? Multiplied 8.2 multiplied cos 0 equals 603. 603 joule is the work done. So here, while lifting an object, see, so here the object is lifted, right? The backpack is lifted, and in the question mass is given, right? So to lift an object, the force required is equal to the weight of the object. So if only mass is given in the question, first you have to calculate the weight. How to calculate the weight of the object? For weight, F is equal to mg, right? Mass multiplied 9.8. So we calculated weight, means we got the force, and we used that value of force in this equation and we multiplied it with the displacement. So we got the answer for the work done. And in some questions weight will be given. If the weight is given, you can use that value of weight for force. Okay, so if weight is given, you don't have to calculate weight, right? You don't have to multiply by 9.8. So how do we know how to identify whether mass is given or weight of the object is given? That you can identify from the unit. So here you can see 7.5 kilogram, which means kilogram is the SI unit of mass. So if the number is with kilogram, means if the quantity is given, data is given in a unit of kilogram, which means that is mass, and if the unit is given in Newton, that is weight. So from the unit you can identify whether it is mass or weight is given. And from that practice problem, same question, okay, same question, question number 3. If the climber weigh 645 Newton, how much does she do lifting herself and the backpack? So her weight is how much? Her weight is 645 Newton. So her weight is equal to 645 Newton. 645 Newton. So she is climbing the cliff. 645 Newton is her weight, and there is a backpack. The mass of the backpack is 7.5 kilogram, and the weight of the backpack, when you calculate, you got it is 73.5. so how much will be the work done to lift her body plus means lift her body together with the backpack? So in that case, total force she has to apply is 645 plus 73.5, the weight of the backpack. So how much is the value of the force? Her weight plus weight of the backpack. So 645 plus 73.5 equals how much? Okay, 719. So 719. We need to calculate work, right? So work is equal to force multiplied displacement multiplied cos theta. So force is how much? 719 multiplied displacement is 8.2, right? So displacement is 8.2 here 8.2. So 719 multiplied 8.2 equals, okay, how much? 5890 joule. So that is the work done. Here I didn't write to cos theta because they are in the same direction, right? If force and displacement are in the same direction, the equation to calculate work done is equal to force multiplied displacement. So no need to write to cos theta if they are in the same direction, because the value of cos theta is 1. If you write or not write, you will get the same answer. And another question from the same page number 192 of the textbook. Practice problem number 4. A girl pushes a 3 kilogram box 7 meter across a floor with a force of 12 Newton. So 3 kilogram and displacement is equal to 7 meter, and she is applying a force of 12 Newton. So the applied force is equal to 12 Newton, and she is lifting that box onto a shelf with a height of 1 meter, means displacement I will again write 1 meter, and mass is given, right? So we need to calculate the total work done. We need to calculate. So this is the ground, and here is a box. A box is here, and there is a shelf here. So what she is doing, she is pushing this box through a distance of 7 meter. So a distance of 7 meter, she is pushing that box, and to push the box she is applying a force of 12 Newton. And what she is doing, after that she is lifting the box after reaching here and keeping a height of 1 meter on the shelf. So this height is 1 meter, and we need to calculate the work done. So we need to calculate the total work done. So here there are two work done. One is to move the box in a horizontal direction. Second is to move the box in a vertical direction. One is to push the box, other is to lift the box to a height of 1 meter. So we will calculate this work done separately, and after that we will add. So to move the box in a horizontal direction, how much work she is doing? So I will just write W1. Work means first work done. To push this box towards the shelf, that is force multiplied displacement, 12 multiplied 7, which equals 84, right? Yes, 84 joule. Okay, then second work done, to lift the box to a height of 1 meter. So to lift the box, we cannot use this applied force. 12 Newton force is applied along the horizontal direction. So to lift the object, to lift the box, how much force we need to use? That force is not given here, but we know that to lift an object you have to apply a force that is equal to weight of the object. So mass is given, right? 3 kilogram. Weight will be how much? Weight will be 3 multiplied 9.8. How much? 3 multiplied 9.8. 3 multiplied 9.8 equals what? 294. Sorry, 29.4. 29.4 Newton. So 29.4 multiplied 1 meter height, right? So that is equal to 29.4 joule. Now what is the total work done? Total work done is first work done plus second work done, means work done to move in the horizontal direction plus work done to lift the box. So that is 84 plus 29.4. How much? Calculate and tell the answer. 84 plus 29.4 equals multiplied. 84 plus 29.4 equals how much? 113 joule. 113 joule. So I'm writing the answer in 3 significant figures. Okay, that is why that 0.4 is not there. So I am just writing the answer in 3 significant figures. So we have discussed some questions in that force and displacement are in the same direction and how to calculate work done, right? How to calculate work done when force and displacement are in the same direction. That is what we have discussed. If they are in the same direction, angle theta is equal to 0, so value of cos theta will be 1. So if you just multiplied force and displacement, you will get the answer. Next we will discuss questions to calculate work done, but in these questions force and displacement are not in the same direction. There is an angle between force and displacement. Example what? Example, like there is a box and I am pulling that box with the help of a rope. Okay, for example, there is a boat in the water and the people are using a rope to pull that boat. So they will be applying force at an angle, and the object will be moving along the horizontal direction. And familiar example is in the airport I am using my trolley. Okay, so in which direction I am applying force? I am applying a force along this direction. Okay, so this is my trolley, I am pulling this trolley like this, so I am applying a force along this direction, at an angle with the horizontal, maybe an angle of 60 degree with the horizontal. But in which direction the trolley is moving? Trolley is moving along the horizontal direction, which means there is an angle between force and displacement. Force is at an angle of 60 degree from the horizontal and displacement is along the horizontal direction. So like that question, so there are some number of questions in the textbook, similar questions, and we have questions that came in the last year examination. So one question that I will discuss here. Selma pulls a suitcase with a force of 50 Newton. So she is applying a force of 50 Newton. So first we have to erase this. She is applying a force of 50 Newton. She is applying a force F is equal to 50 Newton. Okay, so this is her trolley, a suitcase, and she is in the airport. This is the airport. So she is applying the force along this direction. How much force she is applying? She is applying a force of 50 Newton. 50 Newton force she is applying at an angle 60 degree. So this angle is 60 degree from the horizontal, and she is pulling the trolley for a distance of 15 meter. Displacement is 15 meter. So what is given in this question? Force is given 50 Newton. Displacement is also given. How much? 15 meter. Angle theta is given 60 degree. What you need to calculate? You need to calculate work done. How to calculate? The equation to calculate work done is force multiplied displacement multiplied cos theta. Force is how much? 50. Displacement how much? 15 cos 60. Take the calculator. 50 multiplied 15 multiplied cos 60. Got the answer? How much? 375, correct? 375 joule, 375 joule. And another question given here, that is two people lift from the practice problem. Okay, from the practice problem, page number 193, two people lift a heavy box. So here this is the floor and here there is a box. Two people lift a heavy box a distance of 15 meter. So they are moving it through a distance of 15 meter, and they are doing this work with the help of two ropes like this. So they are tying here one rope like this. Okay, both of this rope make an angle, same angle, 15 degree with the vertical. So this is the vertical direction, so this angle is 15 degree, this is 15 meter, so this angle is 15 degree and this also 15 degree. And how much is the tension here? The tension in the wire is 225 Newton, 225 Newton. So here also tension is 225 Newton. We need to calculate the work done. Work done is equal to force multiplied displacement multiplied cos theta. How much is the force? So here we have two forces. So I will write 2 multiplied 225 multiplied displacement, how much? 15 meter multiplied cos. What is the angle between force and displacement? Angle between force and displacement is 15 degree. Cos 15, right? So here angle theta is always the angle between force and displacement. So here force is along this direction and displacement along this direction. Angle between force and displacement is 15 degree. So the answer is 2 multiplied 225 multiplied 15 multiplied cos 15, which equals 6520 joule. So what have you learned here? In any question, to calculate work done, if the angle is given, what is the equation? The equation is force multiplied displacement multiplied cos theta. So we have to multiply force, displacement and cosine of the angle. If force and displacement are in the same direction, then angle will be equal to 0. In such questions, angle will not be given. If force and displacement are in the same direction, angle will not be given. So you can use 0 for the value of angle, or you can just use the equation work is equal to force multiplied displacement. No need to use the angle if angle is not given. But if the angle is given in the question, force multiplied displacement multiplied cosine of that angle, that you have to use the angle to solve the question to calculate work done. That is what you have learned in question number 8. The next question is question number 7. Work done by a perpendicular force. Question 7. Work by a perpendicular force. Work done by a perpendicular force, that will be always equal to 0. Work done by a perpendicular force is always equal to 0. For example, sun here and earth is here. Earth is moving around the sun in a circular orbit. This is the earth. So earth, what is the direction of motion of earth at this point? If you draw the tangent, this is the direction of motion of the earth, and the gravitational force will be acting from the center to the center. So this angle will be 90 degree. The angle will be 90 degree. That is called perpendicular force, right? If the force is at an angle 90 degree to the direction of motion, we call that force perpendicular force. So if you calculate the work done by a perpendicular force, work done equation is force multiplied displacement multiplied cos theta. So for work done is equal to force multiplied displacement multiplied. If the force is perpendicular, the angle will be 90 degree. And what is the value of cos 90? The value of cos 90 is equal to 0. The value of cos 90 equal to 0. So work done is equal to force multiplied displacement multiplied 0. It will be 0. Work done by a perpendicular force is always 0. What is the work done by gravitational force of sun on earth? equal to 0. What is the work done by gravitational force of Earth on the moon? Equal to 0. Why? Because the gravitational force of Earth on the moon is perpendicular to the direction of motion of the moon. So if the if the force is perpendicular to the direction of motion, if the force is perpendicular to the displacement, work done is equal to 0. For example, this my bag or any like a suitcase, brick, anything. So if I hold like this, in which direction I am applying force? To support its weight, I am applying a force in the upward direction. I am applying a force in the upward direction. What is the direction of the force? Upward, right? So I am moving this, okay, I am moving like this. So what is the direction of the displacement? Displacement is along this horizontal direction. If this is the direction of the displacement, what is the in which direction I am applying force? To support its weight, I am applying a force along the upward direction. See, the direction of the force and direction of the displacement, what is the angle? Angle is 90 degree. So work done is equal to 0. Why? Because force is perpendicular to the direction of displacement. So there is another question in the examination. Salim ties a ball to the end of a string and he rotates, means he swings the ball in a circle. So he is tying a stone, right, a ball to the end of a string and he is rotating. So what is the work done here? The work done is equal to 0. Why? Because the centripetal force, right, centripetal force, direction of centripetal force is always perpendicular to the direction of motion. So work done by a centripetal force is equal to 0. Why? Because the force is perpendicular to the direction of motion. Work done by a perpendicular force is 0. That is a question in the last year examination. And another question from the last year examination. A waiter walks with a distance 3 meters holding a tray of food that weight 10 Newton, and how much is the work done? For example, this is the tray. The waiter is holding the tray like this to support the weight of the tray. In which direction he is applying the force? He is applying the force in the upward direction. Okay, so he is applying the force in the upward direction and he is walking like this. So he is walking in a horizontal direction. The displacement is horizontal direction. Force is in the vertical direction. This is the direction of the force, direction of displacement. Angle between them is 90 degree. What is the value of cos 90? 0. Value of cos 90 is 0. That is why work done by perpendicular force is 0. So what you have to understand? Number 1, work done by the gravitational force of sun on earth, how much? 0. Work done by the gravitational force of earth on the moon, how much? 0. Why? Because angle between force and displacement is 90 degree. Value of cos 90, 0. So work done by perpendicular force is 0. If a person holds a suitcase like this and he walks, what is the work done? 0. Why? Because the direction of the force is like this in the upward direction to support its weight, and displacement in the horizontal direction. Angle between them 90 degree. Work done is equal to 0. Why? Value of cos 90 is 0. A waiter, he is holding a tray like this. In which direction he is applying a force? In the upward direction. Displacement in the horizontal direction. Angle between them 90 degree. Work done 0. Why? Cos 90 is equal to 0. So this is question number 7 in the Hikel in the EOT. Work done by a perpendicular force, that is equal to 0, and we have discussed different context of work done by a perpendicular force. Then concept number 2, that is calculate work from the graph. How to calculate work done from a force displacement graph given. And we have one question in the EOT from this concept, that is question number 18, to calculate work done from a given graph. So this will be a force displacement graph. So in that, the force will be on the y-axis and displacement on the x-axis. Okay, force displacement graph, right? Force on the y-axis, displacement on x-axis. So I'm just drawing three different graphs. Force on y-axis, displacement on the x-axis. Force multiplied displacement is the work done. So how to calculate work from force displacement graph? From the graph, work is equal to area. Work is equal to what? Work is equal to area under the graph. So how to calculate work done from a graph? By calculating area under the graph. Okay, by calculating area under the graph. For example, if this is a graph given, so what is the area under this force displacement graph? Area under this graph is this area, right? This much area. So what is the shape of this area? Shape of this area is a rectangle. How to calculate area of the rectangle? Area of the rectangle is equal to the length multiplied the breadth, right? So I will just write L multiplied B, means this side multiplied this side. If this side is 5 meter and this side is 4 Newton, so it will be 5 multiplied 4, so 20 joule will be the work done. So you can calculate work done by calculating area under force displacement graph. So if the graph is like this given, what is the area under this line? Area under this line is this area, right? What is the shape of this area? A triangular shape, correct? A triangle. How to calculate area of triangle? Half multiplied length, right? Half BH. This breadth multiplied the height. Okay, so half multiplied this side, length of this side multiplied length of the height. Then if the graph is like this given, how to calculate area of this type of graph? So this is a trapezium, right, or trapezoid. So what is the area under this graph? This area, right? What's the shape of the area? Shape of the area is a trapezoid. What is the equation to calculate area of a trapezoid? The equation to calculate area of trapezoid is how area is equal to half multiplied A plus B multiplied height. So a trapezoid means it will have two parallel sides. You can see this side and this side are parallel. What? This side, right? This side and this side are parallel. We call one of this side A, other side B. It can be A, it can be anything. Any of the parallel side is A, the other parallel side is B. Okay, and this is the height, or we can call this is the height. So half multiplied A plus B multiplied height. Or what you can do to calculate area of trapezoid, you can divide this into a triangle and a rectangle. Then calculate area of this triangle and area of this rectangle. Then add both the area. So a question from the last year examination. The graph sketches a variable force moving an object in its direction. What is the net work done to move the object for first 30 meter? So it's like this, the graph. So the shape of the graph is like this, and this is marked as 300. So 300 Newton force on the y-axis, force on y-axis, displacement on the x-axis, and here it is marked 20, and this is marked as 30, and here it is 60. So this is the given graph. The question is calculate the work done to move the object for first 30 meter. To move the object for first 30 meter. So graph is given and the question is calculate work done. If force displacement graph is given, what is work done? Work done is equal to area under the graph, right? Area under the graph. So what is the area under this line till 30 meter? Till 30 meter area under the line is like this, right? So till 30 meter, this is the area. Okay, this area. So what is the shape of this area? Is it a triangle? Is it a rectangle or a trapezoid? This is a trapezoid, right? What is the equation to calculate area of trapezoid? Area of trapezoid is equal to half multiplied a plus b multiplied height. So I will just, area is equal to work done, so half multiplied a. I said a trapezoid will have two parallel sides. So this is one of the parallel side, this is the other. So these two sides will be, means any, like two sides will be parallel for a trapezoid. So A and B are the parallel sides. So this one we need up to 30 meter, right? So this side is equal to 30 meter. So I will write 30 means 30 plus this side B, right? One of the side is A, other side is B, but we need up to 30 meter only. So we need up to here, from here to here, right? B. So what is from here to here? It is 30 minus 20, right? From this is 20, right? And this is 30. So from here to here it is 10, right? So 30 plus 10 multiplied height. What is the height of the trapezoid? This is the height. Height is how much? Check here. Height is 300, right? So 300, which is equal to half multiplied 30 plus 10 is 40, right? Multiplied 300. So it will be half multiplied 40. It will be 20, right? 20 multiplied 300, 6000 joule. 6000 joule is the work done. So if a force displacement graph is given, work done is equal to area under the graph. So you need to check, first you need to check what is the shape of the area under the given graph. If it is a rectangle, use the equation to calculate area of the rectangle. If the shape is a triangle, use the equation to calculate area of a triangle. If the shape is a trapezoid, use the equation to calculate area of a trapezoid. And remember one thing, you need to always calculate the area within the given range. So here they ask to calculate the work done till the first 30 meter. So you have to calculate area under the graph till 30 meter only. You don't have to calculate area under the, means you don't have to calculate the complete area. You have to calculate area up to the given range in the question. The next is concept number 3, energy. From energy we have 3 questions in the EOT. Question number 2, question 5 and question 10 of EOT are from this topic, energy. So in energy we are studying 3 things. One is kinetic energy, second is potential energy, and third is work energy theorem. What is kinetic energy? Kinetic energy of an object is energy possessed by the motion of the object, energy due to the motion of the object. If an object is in motion, it will have kinetic energy, and if the object is not moving, means if the object is stationary, its kinetic energy will be 0. So kinetic energy is due to motion of the object. So I will just write here motion. What is the equation to calculate kinetic energy? The equation to calculate kinetic energy is half mv squared 1 by 2 multiplied, m means mass multiplied, v is the speed, square of the speed. So half multiplied mass multiplied speed of the object squared, that is the equation to calculate the kinetic energy of the object. Potential energy, energy due to the position or height of the object. How to calculate potential energy? To calculate potential energy, the equation is mg multiplied the change in height. Here delta h represent the change in the height, final height minus initial height. So mg delta H, that is the equation to calculate potential energy. And third one is work energy theorem. Work energy theorem states that work done is always equal to change in kinetic energy of the object. So kinetic energy I will represent by Ke. Work energy theorem states that work done on an object is always equal to change in its kinetic energy. That is the work energy theorem. Now we will discuss question number 2 from the EOT. Question number 2 from EOT. A 875 kilogram car speeds up from 22 meter per second to 44 meter per second. What are the initial and final kinetic energy of the car, and how much is the work done to increase its speed? So a car is moving and the mass of the car is given in the question. The mass of the car, that is equal to 875 kilogram, and the car is moving at a speed of 22 meter per second. So its initial speed, to represent initial speed I will write Vi. The initial speed is 22 meter per second, and it is increasing its speed to 44 meter per second. So its final speed is 44 meter per second. How much work is done on the car to increase its speed? So first we need to calculate the initial kinetic energy. We need to calculate. Then we need to calculate the final kinetic energy, and we have to calculate the work done. So we know the equation to calculate kinetic energy. Kinetic energy is equal to half mv squared. So first we will calculate its initial kinetic energy, Ke, kinetic energy, and to represent initial I will write I here. So initial kinetic energy, that is equal to half multiplied mass multiplied its initial speed squared. Initial speed we will write by Vi, represent initial speed. So initial speed squared. Now we will substitute values. Half multiplied, what's the mass of the car? Mass of the car is 875 kilogram. So 875 multiplied speed squared, initial speed squared. What's the initial speed? 22, right? So 22 squared, which equals, we will calculate 0.5 multiplied 875 multiplied 22 squared, that equals 2.12 into 10 to the power 5 joule. 2.12 multiplied 10 to the power 5 joule. Now we will calculate the final kinetic energy, Ke, kinetic energy. To make it final I will write F here. So final kinetic energy equal to half multiplied mass multiplied final speed squared, which equals half multiplied 875 is the mass of the car multiplied final speed is 44 squared, that equals 5 multiplied 875 multiplied 44 squared equals 8.47 into 10 to the power 5. 8.47 multiplied 10 to the power 5 joule. What do we have to calculate? We have to calculate the third one. We have to calculate work done. So work done, that is equal to, we know that work energy theorem states that work done is equal to change in kinetic energy. So delta Ke, that is the change in kinetic energy. To calculate change of anything, that is final minus initial, right? Change is always equal to final minus initial. So change in kinetic energy, that is final kinetic energy, I will write Ke final minus Ke initial. So change in kinetic energy is always final kinetic energy minus initial kinetic energy. So what's the value of the final kinetic energy? This one, right? And this is the value of the initial kinetic energy. Now we will subtract both, which is equal to 8.47 multiplied 10 to the power 5 minus 2.12 multiplied 10 to the power 5 equals 2.12 multiplied 10 to the power 5. So 6.35 multiplied 10 to the power 5 joule is the answer. 6.35 multiplied 10 to the power 5 joule is the work done. So work done is always equal to change in kinetic energy, that is the work energy theorem, which means final kinetic energy minus initial kinetic energy. So if two speeds are given, if the initial speed and final speed and the mass of the object, if these three things are given, the mass of the object, initial speed and the final speed, and the question is to calculate work done, how will you calculate? You will calculate using work energy theorem, that is work done is equal to final kinetic energy minus initial kinetic energy. First calculate the initial kinetic energy, then calculate the final kinetic energy, then find the difference, subtract final minus initial, that will give you the work done. Another question from work energy theorem, and this question from the last year examination. A 2 kilogram box is moving with an initial velocity of 10 meter per second on a rough surface. If the box come to a stop after traveling a distance of 5 meter, what's the magnitude of the frictional force acting on the box? So here this is a floor, and on this floor there is a box, its mass is 2 kilogram. So here we have a box, the mass of the box is 2 kilogram, and this box is moving towards the side, and its initial speed is 10 meter per second. It's moving with a speed of 10 meter per second. Then after moving 5 meter it stops. So after traveling 5 meter the box is here. So after traveling a distance of 5 meter the box stop. We need to calculate what is the force acting on this. So we know that the box stops because of the frictional force, right? So frictional force will be acting along this direction. So this is the frictional force that will be always acting opposite to the direction of motion, that's the direction of the frictional force. So here we will use work energy theorem to calculate the force. So in this question we need to calculate the force. What is the value of this frictional force that stopped the motion of the box? So force we need to calculate, and what is given? The mass is given. Mass is how much? 2 kilogram. So initial velocity or initial speed of the box is given, that is 10 meter per second. And what is the final speed? Use the common sense. After traveling 5 meter it stops, right? The box stops. So its final speed will be 0. And we know that from work energy theorem, we know that work done is equal to final kinetic energy minus initial kinetic energy, that is half multiplied m multiplied final velocity squared, this is final kinetic energy, minus half multiplied m multiplied initial speed squared, this is the initial kinetic energy. So we will use the values. Half multiplied, what is the mass of the box is 2 kilogram multiplied final velocity 0, minus half multiplied mass is 2 kilogram multiplied initial velocity is 10 meter squared, so 10 squared. So this one we will get work done is equal to this term, half multiplied 2 multiplied 0. If anything is multiplied by 0 it will be 0. So 0 minus half multiplied to this 2 cancelled, so 10 squared is 100. So we will get negative 100 is the work done. Negative 100 joule is the work done. So why the negative? Negative is because here work is done by the object. If work done is by the object, it will be negative, because the box is doing the work against the frictional force, so the box is losing its energy. So work done is negative. What is the meaning of negative work done? Negative work done means work is done by the object. When work is done by the object, it will lose the energy. That is why work done is negative. When the system loses the energy, work done is negative. Okay. We know that work done is always equal to force multiplied distance, right? So force multiplied distance, that is equal to negative 100 joule. What we need to calculate? We need to calculate the force. So negative 100 divided by distance. How much is the distance traveled? Distance traveled is 5 meter, right? Distance traveled is equal to 5 meter, that is given in the question. So negative 100 joule divided by 5 meters, that is equal to 100 divided by 5 is 20, right? So negative 20 Newton is the force. Why the force is negative? It is because the direction of the force is opposite to the direction of motion. Why the force is opposite to the direction of motion? Because it is the frictional force. So the force of friction, the value of the force of friction is negative 20 Newton. So here negative represent, the negative sign represent the direction of the force is opposite to the direction of motion of the box, and we know that that is a frictional force. One more question from the last year examination. This is to calculate the speed of the object from the work energy theorem, or using work energy theorem we need to calculate the speed of the object. So in a curling game, a player does work to slide a stone of mass 2.5 kilograms. So here mass of the stone is 2.5 kilogram, and a player does work to slide a stone of mass 2.5 kilogram from rest on the surface, on an ice surface. He exerts a horizontal force of 40 Newton. So its initial speed is given. Initial speed is equal to 0, because the stone was initially at rest, so initial speed is 0, and he is applying a force of 40 Newton, and he is moving the stone is moved by a distance of 1.5 meter. Distance is 1.5 meter, and the question is to calculate the final speed. We need to calculate the final speed. Initial speed is given because it is starting from rest. So this is the floor here, an ice floor, and the stone is here. So ice floor is given because there is no friction. Okay, so friction is 0, friction is negligible. Okay, so it is given that in the question, consider the ice surface is frictionless. So this is the stone. A force is applied on this stone. The value of the force is 40 Newton, and the stone is initially at rest, so its initial velocity is 0. Then the stone is moved through a distance of 1.5 meter. So what will be its velocity of the speed when it reach here? So we need to calculate the final speed or final velocity. So how to calculate the final speed? So first we will calculate its kinetic energy. So its initial kinetic energy is 0, right? Because it is initially at rest. So initial kinetic energy is 0. Then what will be the kinetic energy here? The work energy theorem states that its change in kinetic energy, that is equal to the work done on the object, right? So we know that the change in kinetic energy, half multiplied m multiplied final velocity squared minus half multiplied m multiplied initial velocity squared, initial, right? Vi, that is equal to work done. That is equal to work done. So here this initial velocity is 0. Why initial velocity is 0? Because the stone was at rest. So initial speed is 0. That's why initial kinetic energy is 0. Then half multiplied, what is the mass here? Mass is 2.5, right? Mass of the stone is 2.5 kilogram multiplied final velocity squared, that is equal to this minus 0, right? Minus initial kinetic energy is 0. So minus 0, I am not writing that. Okay. That is equal to work done. So what is work done? Work done is force multiplied displacement, right? How to calculate work done? Force multiplied displacement. So work done is force multiplied displacement. So I will just write this half multiplied 2.5 multiplied final velocity squared, that is equal to force how much? 40, displacement how much? 1.5. So force multiplied displacement means 40 multiplied 1.5, that is equal to 60, right? 60. So to reduce step, I will write 60 here. 60. Then we need final velocity squared, right? So this term we will take to the other side of the equation. Half multiplied 2.5, that will be equal to 1.25, right? Half multiplied 2.5 is 1.25. So we can write like this: final velocity squared, that is equal to 60 divided by 60 divided by 1.25, means half multiplied 2.5 is 1.25. We need to calculate the final velocity, right? Not final velocity squared. We need to calculate final velocity. So what I will do is I will remove the square. How to remove the square? By taking square root here. Equals how much? Square root 60 divided by 1.25, 60 divided by 1.25 equals 6.93. 6.93 unit of speed is meter per second. So what is its initial speed? We calculated the final speed, right? We calculated the final speed and we got 6.93 meter per second. How did we calculate? By using work energy theorem. The change in kinetic energy, that is equal to work done. Then the next is question number 5 from the EOT. Question number 5 is about the kinetic energy. The question is, it is from page number 198 of your textbook, and question number 20. If the work done on an object double its kinetic energy, does it double its speed? So if kinetic energy is doubled, will the speed double? If speed is not doubled, by what ratio it will change? So to know that, first we have to write an equation for speed in terms of kinetic energy. So we know that kinetic energy equation, the basic equation for kinetic energy, that is half mv squared. I hope this equation will be given in the examination paper or in the online examination. So we will change this equation to write an equation, or to make v as the subject, or we will write an equation for v, the speed. So what I will do is, first I will take this 2 to this side of the equation, so it becomes like this: 2ke, that is equal to mv squared. We will keep the v squared here, we will take m to this side of the equation, so it becomes 2ke divided by m, that is equal to v squared. So when I rewrite this equation for v, it become like this: v equals, I need to just remove the square. So to remove the square, we need to take the square root of 2ke divided by mass. So the question is, if kinetic energy is doubled, what will be the change in the speed? So we know that speed is proportional to square root of kinetic energy, right? Square root of kinetic energy, or kinetic energy is in the square root. So it become like this: 2 multiplied, so Ke, if the kinetic energy is doubled, which means if the kinetic energy become 2 times kinetic energy, what will be the change in the speed? The speed become the new speed, okay? It will become root 2 times the initial speed. So when kinetic energy is doubled, speed will not become 2 times, speed become root 2 times. For example, if the initial speed, so I will just write v1 is equal to 2 meter per second. Then if kinetic energy is doubled, kinetic energy of the object is doubled. How? By doing a work. You are doing a work on the kinetic on the object, and the kinetic energy of the object is doubled, so the change in its speed will be root 2 times the initial speed. What is the initial speed? 2, right? So if kinetic energy become double, speed become 2 times, root 2 times. If the kinetic energy is tripled, what will be the change in speed? Root 3 times. If the kinetic energy is 4 times increased, the speed will change by square root 4 times. Question number 10 from the EOT, that is to calculate the potential energy. So question number 10, question 10. Question 10 from EOT, that is to calculate the potential energy. And this question is the question number 32 of page number 205 of your textbook. A boy lifts a 2.2 kilogram book from his desk, which is 0.8 meter high, to a bookshelf that is 2.1 meter high. What is the potential energy or change in the potential energy of the book? So here we have this is the floor, and there is a table here. And what is the height of the table? This table has a height of 0.8 meter. The height of the table is 0.8 meter. So from the ground to this table, the height is 0.8 meter. And here is a bookshelf. Here is a bookshelf, and there is a book here, and the mass of the book is how much? The mass of the book is 2.2 kilograms, so it is a heavy book, 2.2 kilogram, and this boy is keeping this book onto this shelf here. He is keeping the book here, and the shelf is at a height of 2.1 meter. 2.1 meter is the height of the shelf from the ground. So we need to calculate the change in the potential energy of the book, or gain in potential energy. We know that potential energy, that is equal to mass multiplied g multiplied change in the height of the object, means change in the position of the object, right? The change in the vertical position. So what is the mass of the object? That is 2.2 kilogram multiplied the value of g is always 9.8 for Earth, and times the change in the height. What is the change in the height? It was at a height of 0.8 meter before on the table, and now it is a height of 2.1. So change in the height is final height 2.1 minus its initial height 0.8. That is equal to 2.2 multiplied 2.2 multiplied 9.8 multiplied 2.1 minus 0.8 equals, so the potential energy is 28 joule. So I will write 28.0 joule is the value of the potential energy of the object, and that is how you need to calculate the potential energy. Potential energy is equal to mg multiplied the change in the height. Change in height means final height minus the initial height. The concept 4, that is our next concept, it is about power. We have two questions from this topic in the EOT, that is question number 3 and question number 19. What is power? Power is rate of doing work. how much work is done in 1 second, that is called power. So the definition of power is what? Power is rate of doing work. Rate of work done. That is power. So power we will represent by the letter P. Power is equal to work divided by time. This W represent work and T represent time. What is the SI unit of work? SI unit of work is joule and SI unit of time is second. So what is the unit of power? Unit of power is joule per second. Unit of power is joule per second. Joule per second, this unit is called what? This unit is called watt. Watt we will represent by the letter W. This when the unit is W, that represent watt. Watt is the unit of power, that is equal to joule per second. And what is the equation to calculate power? The equation to calculate power is work done divided by time. Work done divided by time is the equation to calculate power. So in almost every question, means in all the questions the time will be given, and in some questions work will be given, in some questions work will not be given. Instead of that, force and distance traveled or displacement traveled will be given. If force and displacement is given, then how to calculate power? So we will write power is equal to, instead of work, we know that work is equal to force multiplied displacement divided by time. So if force and displacement is given, then first we will calculate the work done by using force multiplied displacement. And in some questions force will be given, displacement and time will not be given. Instead of that, the speed will be given or the velocity will be given. So instead of force and displacement in a question, if speed is given, force and speed is given, then how to calculate power? So in that case also you can calculate power using this equation. Power is equal to force multiplied. What is displacement divided by time? What is displacement by time? Displacement by time is equal to velocity. Displacement by time is equal to velocity, so force multiplied the velocity. So power is equal to force multiplied speed. So I have given you three equations to calculate power. Power is work done divided by time. If work and time is given in the question, use this equation. Power is force multiplied displacement divided by time. In the question, if force and displacement with the time is given, use this equation. And in the question, if force and speed is given, use this equation to calculate power. Now we will discuss some questions. Before that, power is a scalar quantity. Power is a scalar quantity. It has no direction. So we have a question from page number 197 of your textbook, that is the example problem 3. An electric motor lifts an elevator 9 meters in 15 seconds by exerting an upward force of 1.2 times 10 to the power 4 Newton. What is the power does the motor produce in kilowatt? So we need to write the answer in kilowatt. So an electric motor and lift an elevator 9 meters. So displacement is given, that is 9 meter is the displacement in this question. Time is given, that is equal to 15 seconds is the time by exerting an upward force also given, that is 1.2 times 10 to the power 4 Newton. We need to calculate the power and we need to express the answer in kilowatt. So we know that here force given, displacement given, time given. So power is equal to force multiplied displacement divided by time, that is 1.2 times 10 to the power 4 multiplied the displacement is 9 meter divided by time is how much? 15 seconds. So we will get the value of power by doing this calculation. 1.2 times 10 to the power 4 times 9 divided by time 115, which equals 15 is the time, right? Yes, which equals 7.20 times 10 to the power 3. 7.20 times 10 to the power 3. The unit of power is watts. So we use the capital letter W to represent watts. So we need the answer in kilowatts, not in watts. In this question it is given, write your answer in kilowatts. So how to change watts to kilowatts? So power is equal to 7.20 times 10 to the power 3. We need to write the answer in kilowatts. To change watts to kilowatts, divide by 1000. So when you divide this by 1000, you will get to 7.2 kilowatts. One question from a last year examination. A weightlifter lifts 300 kg from the ground to a height of 2 meters in 3 seconds. What is the average power generated? So a weightlifter is lifting 300 kg. So the mass which he is lifting is 300 kg from the ground to a height of 2 meters. The height is 2 meters, and the time is given. Time is equal to 3 seconds. We need to calculate power. So here you can see displacement given, time given, force is not given, but mass is given. We know that lifting, right? The power lifter is lifting the mass. So in such questions, usually the mass will be given. If something is lifted like this, something is lifted, so mass of the object is given, and you need to calculate the force, how much force he has to apply. That is equal to mg, right? The force he has to apply is mg. So here force is not given, only mass is given. So we will calculate the force by using like this, 300 multiplied 9.8. So to lift an object, you have to apply a force that is equal to weight of the object. Okay, force is equal to weight. To lift, force equal to weight. Remember like that. To lift, force is equal to weight of the object. So 300 multiplied 9.8, that equals 300 multiplied 9.8 equals 294. Sorry, 2940 Newton. So now we got the force and we need to calculate power. We have the equation, power is force multiplied displacement divided by time. Force is 2940 multiplied displacement is how much? 2 meters, right? 2 meters divided by time how much? 3 seconds. So the multiplied 2 divided by 3, that equals 1960 watts. 1960 watts. If you want the answer in kilowatts, change this into kilowatts by dividing by 1000. So it become like this, power is equal to 1.96 kilowatts. If you want to change into kilowatts, divide by 1000. So power is 1.96 kilowatts. Another question from the last year examination, that is a crane lift a load of 500 kilogram to a height of 120 meter in 16 seconds. What is the power developed? So similar question. Here the mass is equal to 500 kilogram and the crane lift this 500 kilogram to a height of 120 meter. So displacement is equal to 120 meter and the time taken is 16 seconds. So we need to calculate power. So here force is not given, mass is given and the crane is lifting the mass. So we know that force is equal to 500 multiplied 9.8, that is the weight of the mass. 500 multiplied 9.8, 500 multiplied 9.8, that equals 4900 watts, 4900 Newton, not watts, okay, Newton. So we need to calculate power. Power is force multiplied displacement divided by time. So force is 4900 multiplied displacement, that is 120, and divided by time. Time is 16, that equals so 3.68. the power is equal to 3.68 times 10 to the power 4, 10 to the power 4 watts, right? 4 watts. If you want this in kilowatts, divide by 1000, that equals 36.8. so if you need the answer in kilowatts, 36.8 kilowatts. Another question from the last year examination. An engine uses a force of 22 kilonewton. So here force is equal to 22 kilonewton. So 22 kilonewton. So kilonewton means 1000, right? Kilo is 1000. So 22,000 Newton is the force. To power a car, an average speed V, if the average power output of the engine is 120 kilowatts, so power is given. Power is equal to 120 kilowatts, 120 kilowatts. So I will just write 120 multiplied 10 to the power 3 watts. This also we will write like that, 22 multiplied 10 to the power 3. What is the magnitude of the average speed of the car? So we need to calculate the speed. Here power is given, force is given, you need to calculate the speed. Power, force, speed. Power is equal to force multiplied speed. If you want to calculate the speed V equal to power divided by force, right? Power divided by force. How much is power? 120 kilowatts, right? So 120 multiplied 10 to the power 3 divided by how much is force? 22 kilonewton. So 22 multiplied 10 to the power 3, right? 10 to the power 3, 22 kilo. 10 to the power 3, 10 to the power 3 cancelled. 120 divided by 22. So 120 divided by 22, 120 divided by 22, that is equals 5.45 meter per second. That is the speed. So here what is given in this question? In this question, force given, right? Force given, power given. The equation is the question is to calculate speed. Power, force, speed, right? Power is equal to force multiplied speed. Speed is power divided by force. Substitute values, do the calculation, you will get the answer. One question from the textbook, that is, an electric motor develops 65 kilowatts of power as it lifts a loaded elevator 17.5 meter in 35 seconds. How much force does the motor exert? So here we need to calculate the force, and what is given in this question? Power is given. Power is equal to 65 kilowatts. So 65 multiplied 10 to the power 3 watts. I'm just changing kilowatts to watts. As it lift a loaded elevator 17.5 meters, so displacement is 17.5 meter, and the time is 35 seconds. We need to calculate the force. So we have this equation, power is equal to force multiplied displacement divided by time. So force you need to calculate. So force is equal to, if you rewrite this equation, it becomes like this: power multiplied time divided by displacement. So what force I am keeping here, and I need to move the other members here, means other terms here, to the other side of the equal to sign. It has to cross the equal to sign. When time cross the equal to sign, if any term cross the equal to sign, it will not cross like this. How does it cross? Cross means, cross is like this, right? This is the cross. So whatever down, it will go up, means whatever in the division, that changes to multiplication. So how displacement go, it is multiplication here, right? Cross means it cross the equal to sign like this. So force is equal to power multiplied time divided by the displacement, that is equal to power is 65 multiplied 10 to the power 3 multiplied time is 35 and divided by displacement, that is 17.5, right? So 17.5 is the double of 35, right? So 65 multiplied to, that is 130 times 10 to the power 3 Newton, right? So when you write this in standard form, it is 1.30 into 10 to the power 5 Newton.